This is video number 4 for sections 7.6 and 7.7, application involving a quadratic function. To wrap things up in this lesson, we'll look at a scattergram problem, and this will give us another opportunity to practice that skill we just learned of finding the equation of a parabola from 3 points. Let's take a look at the situation we've got here. It looks like we're studying the price of airplane fuel. So the price of gas that's used in airplanes. And if you look at the table, you've got a bunch of years given, and then you've got some prices. The units are kind of funny. It's cents per gallon instead of the usual dollars per gallon. I did that so that we wouldn't have to work with decimal points. But when you see 165, that would mean $1.65, of course. Here is our typical let statement. And we want to make sure we know what our variables stand for. So P is going to be the price of the airplane fuel in cents per gallon, just like it's given. Great. T is the number of years since the year 2000. So as it says down here, we are going to have to adjust that data, right? Let's do that real quickly. This would, of course, be 0, 1, and then so on. And then our next step, now that we've adjusted our data, is to go to the graphing calculator and draw a scattergram. Let's do that. All right, let's run through those steps quickly. We go Stat, we go Edit. I got to clear out what was there before. Name of the list, clear and enter. Name of the list, clear and enter. And then I can enter in my year information in the first column, just the numbers 0 through 8. And then in the second column, I'll list my fuel prices. And then once I have those numbers entered, I go to my y equals area. Let me clear out anything else that was there. I need to turn on my plot by going up to it, hitting enter to make sure it's highlighted. And then zoom 9 gives me that great window where I can see the scattergram. So here's my picture of my data. The next question on the handout says, what type of function should we use? And this one is not a perfect parabola, but you can still see that the dots go down and then they go up. I can imagine a parabola fitting this data decently well. So we'll go ahead and we'll use a quadratic function. Now, take a look at part C on the handout. We did a couple of scattergram problems earlier in this chapter, and we kind of cheated because all we knew how to work with back then was vertex form. So we would pick one of the points and we would pretend it was the vertex. That's not really a good idea. I have no idea what the vertex is, so I need to find the equation of this parabola the new way, the way where we pick 3 points and we use those points to find the equation in standard form. Now there is a note on the handout that gives a suggestion of which points to pick. It says, why don't you go ahead and pick the one that does look to be the closest to the vertex? Well, that would be this third point. That's clearly the lowest point on there. And then the suggestion is pick one point that's over on the left side and pick one point that's over on the right side. On the left, I don't have much to choose from. I'm feeling like this guy here is somehow a little too low, so I think I would pick the second point. So far I've got the second point and the third point. On the right side, I have a lot to choose from. I kind of want to pick something that's a little farther out to make sure that it heads up in that direction. This guy here looks out of the pattern. I wouldn't pick that. I'm thinking the very last point seems reasonable to me. So I think we're saying the second point, the third point, and the last point. Okay, so the second point and the third point and the last point. Let's write down the coordinates of those 3 points here. It would have been very difficult to know which points to pick without making that scattergram. Now that we have our 3 points, though, we can go ahead and we can find the equation of the model. We're just going to run through the same steps we did in the last video. We're using standard form here. Let me jot that down as a reminder. And now, since these 3 points are just xy points, I temporarily plug in each one. Let's go ahead and do that quickly. Remember, you're just plugging in 1 for the x and 78 for the y, followed by 2 for the x, 71 for the y, and so on. We should simplify these three equations now. You know, after you do this for a while, you might realize that you can just go straight to this step right at the beginning. It's really pretty straightforward. As we said before, the coefficient in front of the a is just each x value squared, and the coefficient in front of the b is just each x value itself, 1, 2, 8, and the c never has a coefficient. So you may be able to just skip all this part and just go right to this. Let me number my equations here. And now the solving begins. We said in that other problem that C is definitely the one always to get rid of first. And in fact, if you just take the simplest equation, in this case equation 1, and multiply through by -1, you can use that same adjusted version with each of the other two in order to get rid of C twice. Let's write down what we're doing then. So I've put down equation 2 and then the adjusted version of equation 1, the one where I've multiplied through by -1. And I know then that if I add these equations together, the C is going to drop out. I get -7 equals 3a plus b. I can do the same thing with equation 3 and the adjusted version of equation 1. And then I can add those two equations together. Let's see, that subtraction problem makes 232, and then I have 63a and 7b. We've gotten rid of the letter C twice. These are equations 4 and 5. Now we take those two equations and form a little 2 by 2 system. Now I need to get rid of one of these letters. Let's see, the numbers with the B's look easier. I think I'll focus there. If I do a times -7 multiplication trick, that should adjust that equation nicely and give me what I need. It becomes +49, -21a, and -7b. And now I can take those bottom two equations there and add them together. And I get 281 equals 42a. The b's drop out. Here's our great equation 6 that has no other letters in it except a, which means I can solve for a very, very quickly. Now remember, this is a real-life type problem. I wasn't expecting that the numbers were going to come out nice. We don't want to work with fractions here, so we'll go ahead and divide that on the calculator. And I got A is about 6.6905. If you look back up at the instructions for letter D, it says keep your decimals long during the problem and don't round until the end. That's again because we're not done using this. So I need to keep several digits. I think 4 is probably plenty. And then later we'll go ahead and we'll round those numbers off when we use them. Our next step is to find B and C. Let's see, for B, I would go back to either equation 4 or 5. Equation 4 looks pretty good to me. So I recopy equation 4, but fill in my A number. And then I'll just need to use my calculator and some algebra to help me finish this off. I got a little bit more than 20 for that decimal, and then just subtract that from both sides, and we're all set. I got B as about -27.0715. And then lastly, I need to find C. I'm going to have to go back to one of my original equations to do that. Let's see. It looks to me like equation 1 is probably the nicest before I multiplied by -1. So let's use that one. That was 78 equals A plus B plus C. That's what I've written down. I've just filled in my A and B numbers. Again, a little bit of calculator work. And when I add that 20 number to both sides, I'm going to get C is about 98.381. Okay, I still haven't written down an answer yet, right? If you could look back at the directions of letter D, our goal was to find the equation of the model. So don't forget to give your final answer. I have the A, B, and C now. I can go ahead and round them off to one decimal place, it says, now that I'm done with all the calculations. I should probably also use the correct letters. Since I'm out of room, let me write it in this space here. So our y variable in this problem was p, and then I have a. If you round a off, you get 6.7, and then I'm supposed to write x squared, but I don't have x, I have t, so 6.7t squared. And then b rounded off would be negative 27.1. That would be the coefficient of the t. And then c rounds off to 98.4. So here is our final model that we're saying does a reasonable job of describing the price of this airplane fuel. Letter E says, let's check it. Let's stick it into the calculator and see if it looks like it fits the data pretty well. All right, I want to leave my scattergram on there and just add in the quadratic function we just found. I'll hit y equals. I'm going to leave the plot turned on. I just need to type in my equation. Of course, I have to use x instead of t, minus 27.1x, and then plus 98.4. And then just hit graph. We'll get a parabola. I'm not expecting it to be perfect. I'm expecting that it'll for sure go through the second, the third, and the eighth points, or the ninth point, I think it was. Those are the ones we picked. But look, it really does a pretty good job of describing the overall pattern here as well. So I'm pretty satisfied with it. Okay, one last question to wrap this all up. Question F. What does your model predict for the price of airplane fuel this year? If this trend continued, what would we expect for this year? I'll use 2017. You can use whatever year you're watching this video in. Let's see, 2017 would be 17 years since the year 2000. I had to go back to my let statement. So that means that I just need to plug in t equals 17 into this equation. It's just a quick plug in, grab the calculator, and we're going to be all set. Let's write it down first, and then just type that into the calculator. That comes out to be 1574. Remember, the units on that are cents per gallon. The more normal way to describe that would be $15.74 per gallon. Is that true? It seems a little high to me. I suspect that prices went down, that they didn't just keep going up in those last several years. But nonetheless, this is what our model predicts.